Alright, this is Math 1, Unit 1B, kind of your review. This is the backside, Part 2. I did a previous video, Part 1, which was the first of 7 problems, so now we're looking at the backside here for the remaining problems here. We begin with looking at some inequalities. For the inequalities, the goal is to get the variable by itself and to solve these, and then we're going to have to graph them out on the number line. So let's begin by moving some things around. I'm going to first of all start by moving the 5x over to here. I choose personally to go that way, so I end up with a positive x variable. It just helps me in the long run. So this will go away, and that, because I'm just subtracting, nothing changes on my inequality. It just comes on down. 7 minus 5 is 2x. While I'm at it, let's go ahead and move the whole number over to this side. So to do that, instead of minus 9, I add 9 to both sides. So 3 plus 9 is 12. Now the goal is to get the variable by itself. So I'm going to go ahead and divide both sides by 2. And so this stays the same here. So x is going to equal, x will be greater than or equal to 12 divided by 2 is 6. Okay, so there's my solution. Now I have to graph that. So I'm going to find the point 6 on my number line. I'm going to draw a circle, but I'm also going to fill in the circle. I do an open circle, recall, if it's greater than or less than. But if it's greater than or equal to, or less than or equal to, then I fill that circle in. We're saying here that x is greater than 6. So we're going to take point 6, we're going to shade it in, and then we're going to draw an arrow this direction to show that it can be any number, any value, greater than or equal to 6. For number 9, not quite as complicated, but it's set up here so you have to work on the one big tricky thing. So let's do this here. I'm going to go ahead and subtract 16 because that's probably what most of you will do. No problem. That goes away. And now I have negative x is less than 19 minus 16 is 3. I can't leave it like that because I want this x value to be a positive value. So I'm going to multiply both sides by a negative 1. Okay? Or I really like to say I can divide both sides by negative 1. It's probably more realistic. So divide by negative 1, divide by negative 1. Okay? So the rule is when we divide by a negative that we have to change the sign. So we're going to change the direction of the sign of the inequality to go that way. And x divided by 1 when negative negative is a positive x. And 3 divided by negative 1 is a negative 3. So in this case here, I'll find my value, negative 3. I'll draw an open circle because it's just greater than. And x is going to be greater than negative 3. And that's my solution and what it looks like as a graph there. Alright, let's move down to number 10. Same idea. Okay, I'm going to go ahead and add 1 to this side, add 1 to this side. So I have negative 4x. Right, and it's going to be greater than or equal to negative 8. I'm going to divide both sides by a negative number. Remember, when I divide by a negative number, I have to then change the direction of my inequality. So negative 4 divided by negative 4 is a positive 1, so I just have x here. And negative 8 divided by negative 4 will give me a positive 2. Right? Negative divided by negative is a positive. 8 divided by 4 is 2. So x is going to be less than or equal to 2. So I can make my number line. Whatever numbers I choose to make them, doesn't really matter. So we have 0, 1, 2, 3. Alright, and here's 2. So I draw a circle. I'm going to fill it in because it's less than or equal to 2. Right, less than or equal to. And because less than, I draw my arrow that way to fill it in, and I'm good there. On the next one, the last one here, I first have to distribute. So this becomes 5x, and I distribute there, minus 35 is greater than 15. I'll add 35 to both sides of the equation in order to get the 5x by itself. 15 plus 35, 10 carry the 1, is 50. Divide both sides by 5, and x is going to be greater than 10. So again, same idea. If I kind of draw this out here, I could say that I have 0. On the one up here, we counted by 2s. I could do 0, 2, 4, 6, 8, 10, 12. Doesn't really matter. You can make your number line however you want. I could write 0 to 10. Doesn't matter. But it's going to be an open circle because just greater than. So there's 10, and it's greater than 10, so then I draw my arrow pointing in a direction that makes everything bigger than 10, and a possible solution to that equation there. Okay. Number 12. So the store is having a sale of half-liter bottles of soda. Right now, we can get 5 bottles for $3.95, right? So basically, for $3.95, I can get 5 bottles. I'm going to just call BTL, okay? The question is, find the cost, it says, for 8 bottles of soda. So what I don't know is what's my cost going to be for 8 bottles. Alright, so knowing this, I have to use this information to then figure out what this number is going to be. I don't see a quick correlation between 5 and 8. I can't multiply by 2 to get 8 or anything like that. So I'm going to have to cross multiply. So I'm going to have to multiply this times this and then work on an equation. So when I do that, if I do $3.95 times 8, when I multiply this out, I have $31. I have 31.60, and that's equal to 5x. Alright, just cross multiplying. So now to get the x by itself, I'll divide both sides by 5, divide by 5, and I end up with 6.32 equals x. Now x, put a dollar sign there, is the value or the cost for 8 bottles of soda. So it'll cost me $3.95 for 5, it'll cost me $6.32 for 8 bottles of soda. Number 13 says Morgan can run 3 miles in 18.2 minutes. So we're doing 3 miles in 18.2 minutes. If maintains, if whatever, he or she, we don't know if Morgan's a he or she, maintains that speed for 91 minutes, how far will he run? So we're going to say, over here, we're going to keep running for 91 minutes. So I want my bottoms to match here. I have minutes to minutes, and I got to go miles to miles. How far we run, we don't know. That's our x, right? So I don't have a nice correlation here, at least not the one that I see. So I'm going to go ahead and cross multiply. I'm going to do 91 times 3, which equals 273, is going to equal that cross multiplying 18.2x. Now to get the x by itself, I divide both sides by 18.2, 18.2 divided by 18.2 on my calculator, and I end up with 15 equals x. So how far will he run after 91 minutes? He'll run 15 miles after 91 minutes. Moving to number 16. We start with feet per second, and we want to convert it to miles per hour. So to set this up, I'm going to start off by saying we have 80 feet in 1 second, right? And you worked on your class a little bit like this. I want to get feet to miles, and I want to get seconds to hours. So let's work on the miles part first of all. Okay? It tells me first of all that in 1 mile I have 5,280 feet, right? That's there, given information. Perfect. So by putting that here, I'll be able to cancel feet and feet. No problem. When I look at the next part, I want seconds to go to hours. So let's go here. There are 60 seconds in 1 minute. Okay, I'm not done yet. But there are also 60 minutes in 1 hour. So I'm looking at the diagonal. Second to second, minute to minute will leave me an hour. Looking at my notes here, I'm crossing out all these little terms here, and I'm left with miles per hour, which is what I want, and now some numbers. So I have 80 times 60 times 60, so 80 times 60 times 60, which equals 288,000, and that's over 5,280. And again, I'm not quite sure if your teacher wants you to reduce this or make that into a decimal. It says here round to the nearest tenth, so you'd have to divide that. So when I do the division here, I end up with 54.5454, and it kind of repeats it on and on. Right? And nearest tenth is going to be here. Because that's a 4, I just kind of truncate it. It means I just stop it. So I'm going to go ahead and stop it here and say it's 54.5 for my solution. Alright. So I can put here 54.5 miles per hour. So the next one, I have 5 feet in 1 second. And what I want to do is get that to, looks like miles per minute. Okay? They gave me this ratio here that says that in 1 mile, or maybe it's meters, I'm not quite sure, it looks like meters, sorry, so meters. So in 1 meter, there are 3.28 feet in 1 meter. Okay? That'll, on the diagonal side, allow me to reduce the feet and make the feet go away. Now the seconds, they want seconds turned into minutes. So I know that there are 60 seconds, again on the diagonal, think diagonal, second in 1 minute. That will leave me with the meters per minute, which is what I want, and now I can do the math. So 5 times 60 is 300, and on the bottom I have 3.28 when I multiply that together. So I have 300 over 3.28 meters per minute. I don't want to stop there, so I'm going to go ahead and do the division. And I end up with 91.463, right? Just got to the 100th, it's fine. Because this is bigger than 5, I'm going to need to round up, right? So that's going to become 91.5 meters per minute will become my solution there. Okay, one last one for our final part here. It says a choral group is buying tickets to see a play when they are in New York. They can buy tickets in groups of 4 at an off-Broadway ticket office for $55. Okay? Or they can buy tickets online in groups of 3 for $39. Solve mathematically and find the cost of 1 ticket in each scenario, and explain which source you would use to purchase tickets and why. Alright, so here's what we know. We don't know how many people, we just know it's a choral group, right? We just know it's a group. Let's call them G for group. Okay? So in the first case, a group can buy tickets in groups of 4, right? So if you have a group of 4, so that 4 times the group is going to get you $55 for 4. Right? Is that right? So if I divide by 4, then that's what I get there. I'm just kind of in my head working this out. I might be doing this wrong actually. Which tells me that the cost, the unit cost here, if I can get 4 tickets for $55, then the unit price here would be $13.75. Over here, I can get 3 tickets, I guess probably right this way. I can get 3 tickets for $39. Or I guess I can probably should flip that actually for you and say, for $39, I get 3 tickets. When I divide that, 39 divided by 3, I end up with $13 per ticket. Alright? So when I go by 4, I have $55 for 4 tickets, which is $13.75. When I have 3 tickets for $39, it costs me $13. So it's actually cheaper to buy them in groups of 3 because the per ticket price is $13. So I would choose the group of 3 in order to buy my tickets. Okay? So that's kind of what you're looking for. You're looking for basically a unit rate to go, well, 55 divided by 4 or 39 divided by 3. Which one is the cheaper unit rate? Hope that helps you. I hope you do a good job on your test. Again, make sure you work out the problems so you can show how you did it, and ask your teacher for more help if you need it. Thanks.